New video regarding the nitrogen and its compound and you can see here some of the important processes which are occurring in our environment due to the nitrogen, like photochemical, smog, acid rain. Also there are some oxides of the nitrogen which I have shown here, ammonia molecule, and some other information about the ammonia along with the nitrogen molecule. So nitrogen in fact playing a very important role in our environment. First of all, nitrogen is a member of the group 15. It is 78% in our atmosphere, and it's the main unreactive gas in air that dilutes the effect of the reactive gas, that is the oxygen. To understand the lack of reactivity of nitrogen, we have to look at the bonding within its molecule. The electron configuration is 1s to 2s to 2p3. The atoms need to gain 3 electrons to achieve the noble gas configuration of neon. So the nitrogen atom do this by forming a triple covalent bond between the two nitrogen atoms. Here you can see this thing. This is a triple covalent bond. Each nitrogen atom in fact contribute with the help of 3 electrons and make a N triple bond N as a nitrogen molecule. Oxidation of nitrogen occur at two places: when there is lightning and in the car when you start the car. So also there is a kind of lightning inside the car carburetor where there is a formation of the nitrogen oxides. Otherwise nitrogen is inert gas, it cannot react with oxygen. So you can see here, this is the step 1. When there is a lightning, nitrogen react with oxygen to make NO, nitrogen 2 oxide. Nitrogen 2 oxide formed is further oxidized by nitrogen in the air to give nitrogen 4 oxide NO2. Then the nitrogen 4 oxide dissolved in water droplets in the air and reacts with more oxygen to form dilute solution of nitric acid. Step 3. The sequence of reaction in the atmosphere forms part of the natural nitrogen cycle. So in this way, nitrogen from unreactive insoluble nitrogen gas can get into soil in the soluble form that the plants can absorb. This sequence of the reaction in the atmosphere forms part of a natural nitrogen cycle. In this question, I just explained that what is the oxidation number of NO2 and what is the oxidation and what is actually occurring there in the previous 3 steps. So actually it is C because oxidation occurring in all the 3 steps. And the oxidation number of NO2 is 4 and that of the HNO3 is 5. Ammonia and ammonia compounds. You can see here, this is ammonia. Ammonia is formed by the reaction of nitrogen and hydrogen. This is artificial reaction. To make the ammonia, the conditions are 150 to 200 atmospheric pressure along with 450 to 500 degrees centigrade temperature and iron as a catalyst. Nitrogen has a lone pair here which did not react with anything. So actually in this way ammonia is formed. Ammonia and ammonium compounds. The positive charge on the ammonium ion formed is spread over the whole ammonium ion. It is when the nitrogen donates its lone pair to the hydrogen. So this bond with the help of arrow which is shown here is in fact a coordinate covalent bond. Ammonia show a kind of basicity because when it reacts with the hydrogen form ammonium ion. Ammonia reacts with the water to make NH4 plus OH minus ion. OH minus ion actually showing the basicity. That's why ammonia showing a basicity. If we heat ammonium salt with the base, the ammonium ion produces ammonia gas. We use this reaction to prepare ammonia gas in the laboratory. Ammonium chloride and calcium hydroxide both in the solid state are usually mixed together when then heated. So basically what we are doing here, that we are heating the ammonium chloride and calcium hydroxide. When we do this, there is a formation of calcium oxide which dry the ammonia, and the damp red litmus paper turns blue here. Nitrogen oxides in the atmosphere. So however, in the extreme conditions, thunderstorm lightning can trigger a reaction between nitrogen and oxygen to form nitrogen oxides. So NO and NO2 are formed. A similar oxidation takes place at high temperature inside the car engine. In car engine, mixture of air, that is 78% nitrogen and 21% oxygen, is compressed and ignited by a spark. Under the high pressure, high temperature, nitrogen can form nitrogen oxides. And these oxides of nitrogen are then released into the atmosphere through the car exhaust fumes. Nitrogen oxides pollute our atmosphere. Acid rain. So basically, as I already explained, that there is a formation of nitrogen oxides, and that nitrogen oxide infiltrate with the water and oxygen in the atmosphere to make HNO3. So if in this way there is a dilute nitric acid formation takes place which fall as a part of the acid rain. Dilute sulfuric is also found in the acid rain. This comes from another pollutant called sulfur dioxide. So nitrogen oxide are as well as causing acid rain directly can also act as a catalyst in the reactions that make the dilute sulfuric acid in the atmosphere. You can see here N and N2 catalyst catalyze the oxidation of sulfur dioxide during the formation of acid rain. This gas, sulfur dioxide, that is produced by oxidation SO2 that will rainwater forming dilute sulfuric acid. You can see here SO3 plus water H2SO4. Now this reaction is very much important because SO2 react with NO2 to make SO3. So NO2 actually working as a catalyst. NO2 actually working as a catalyst convert SO2 into SO3. NO2 is regenerated as NO react with oxygen in the air. So NO2 is working as a catalyst. This is the most bigger problem in this respect. Photochemical smoke. The oxides of the nitrogen also dangerous in the atmosphere because they react to make other pollutants. These are the pollutants called secondary pollutants. For example, they are they are not vehicle exhaust gases or gases from the power plants. Nitrogen oxides are examples of primary pollutants. Other primary pollutants in the exhaust streams are volatile organic compounds (VOCs). They are largely unburnt hydrocarbons from the fuel and their oxidized products. The VOCs are react in sunlight with oxides of nitrogen to make peroxyacetyl nitrate (PAN). Its chemical formula is written as this. Sunlight provides the energy needed to start the reactions as well as in the atmosphere, so we call the photochemical reaction. PAN is one of the most harmful pollutants found in the photochemical smoke. It affects lungs and eyes, and high concentration also affects plant life. So how we can reduce the effects? Basically, we can reduce the effects by removing the pollutant gas from the atmosphere, and we can do this with the help of platinum. Platinum in the catalytic converter can in fact convert the nitrogen oxides into nitrogen gas. So Ca plus NO, Ca2 and N2. This is the reaction taking place in the catalytic converters of the cars, which is in fact installed before the exhaust pipe. That's it for today's video, and I will see you in the next video. Thank you very much. Allah Hafiz.